What's good, math family? In this video, we're going to look at the three key methods to solve systems of equations. We're going to break down each method so that you can solve any type of systems of equations problem. The first method to solving systems of equations is by graphing. And when we have the equations in standard form like this, what we want to do is graph by intercept. So I make my x0 and I solve for y. So I know y is going to be equal to 1. And just remember that these are ordered pairs. So we're talking about the ordered pair 0, 1. That's the first point we're going to plot on our graph. Repeat the process. Now we're solving for the x variable. Negative x is equal to 1. But variables by themselves cannot be negative. So we're going to divide by negative 1. So we get x is equal to negative 1. So our second ordered pair is going to be negative 1, 0. We plot our 2 points and we could draw a line through it. And this is what the line for the first equation is going to look like. Now for the second line, we go back and repeat the same process. So x is 0, we know y is going to be equal to 3. So we're talking about the ordered pair 0, 3. We go back and do the same thing for x. So now y is 0. And we know x is also equal to 3. Talking about the ordered pair 3, 0. Now that we have those 2 points, what we want to do is just draw the line through it. And what we're specifically looking for is the point where these 2 lines intersect. That is going to be our solution. And when we look at this graph, these 2 lines intersect at one point. That one point or one solution is going to be at 1, 2. So if we plug this point into any of these 2 equations, it's going to be a true statement for both of them. Any other point will not satisfy both equations, just one. Now let's say we erase and we go back and we plot these points if they gave it to us in slope-intercept form, because you have to also know how to graph in that form as well. First, to get these equations in the slope-intercept form, it's going to follow that format. Y is equal to mx plus b. So we're basically going to isolate the y. So after I add x, what we're going to be left with is y is equal to x plus 1. When we graph this, the first point we're going to make is the y-intercept, which is 1 that you see me circling in red. Then if we use our slope, 1 over 1, right? That means I'd go over 1, down 1. So there goes our first 2 points for the first line. When I go back and we repeat this process, all right, we move x over. This time we're going to subtract since it's positive. Y is equal to negative x plus 3. So when we look at this equation now, our y-intercept, which we're going to try in purple, is going to be at positive 3. And if we follow this slope, it's negative, meaning we go over 1, down 1, we're going to be on this second point. So please understand how to graph in slope-intercept form and how to graph in standard form to solve the systems of equations. We're looking for the point where these 2 lines intersect. The second method of solving systems of equations is the elimination method. And with the elimination method, we want to get rid of either variable, either x or y. And to do that, we have to pay attention to the coefficients. And we pay attention to the coefficients because we want them to have the same coefficient, one being positive, one being negative. In a problem like this, students are going to focus on the first 2 terms, 3x and 2x. And they're going to multiply the first equation by 2 and the bottom equation, equation number 2, by negative 3, so that we'll have a positive 6 and a negative 6 to cancel out. That is a correct step. However, I don't think it's the best way to approach this problem. When we look at our y's, all we have to do is multiply once. So I could come in here, create an equivalent expression for equation 1. So I'm going to multiply the entire equation by negative 2. So this now turns into negative 6x minus 6y is equal to negative 30. This is an equivalent expression. Now the bottom equation is going to stay the same because I'm trying to cancel out my y's. And when we pay attention to the y's, we notice that we have a negative 6 and a positive 6. So they're going to cancel. What we're left with now is negative 4x is equal to negative 28. We just combine our x's coefficients. Divide by negative 4 to get x by itself. We're going to get x is equal to positive 7. Now, this is just half of it, the half of the problem done. We need to go back and plug in to either equation number 1 or 2 to figure out what is y. So I'm going to go into equation number 1 and substitute. So we have 3 times 7 plus 3 times y is equal to 15. Simplify to 21 plus 3y is equal to 15. At this step now, what we're going to do, we're going to subtract. So we're left with 3y on the left side of the equation is equal to 15 minus 21, which is negative 6. We're going to divide by 3 now and get y is equal to negative 2. So the ordered pair, or the solution to the systems of equations, would be the ordered pair 7, negative 2. If we plug this back into equation 1 and 2, we're going to get a true statement, meaning left side equals the right side of the equation. And now we're going to go on to the last method of this video. The last method to solve systems of equations is going to be the substitution method. And with this method, we want to isolate one of the variables and then solve by plugging into the other equation. So in this type of problem, we're going to want to focus on equation 1 and substitute or solve for y. So to do that, we're going to isolate y by subtracting 2x. Y is equal to negative 2x plus 6. So this expression that you see me highlighting, this is what we're going to substitute. And we're going to substitute it into the second equation. So the second equation is 3x plus 4y, but y is replaced with negative 2x plus 6, and this is equal to 4. So we're not going to add 3x and 4, we're going to distribute, then combine any like terms. So we have 3x minus 8x plus 24 is equal to 4. Simplify to get negative 5x plus 24 is equal to 4. After we subtract 24 and combine our constants, we have negative 5x is equal to negative 20. And then we're going to divide. So x is going to be equal to positive 4. So we go back to the first equation because this is the simpler one. We could use equation 2 if you want. And we're going to plug in and solve for the other variable. So we have 2 times 4 plus y is equal to 6. We simplify this to get 8 plus y is equal to 6. After we subtract 8, we know y is equal to negative 2. So the solution to the systems of equation, remember, is an ordered pair 4, negative 2. So this is the point where these two lines are going to intersect and be equal to each other. But before we go on to the last problem, if this video has been helpful, we're going to ask that you smash the like button for us, math family, so we could continue putting out content that you guys want to see. So another common thing that you'll see with this topic is they'll give you a problem like this. So that's equation number 1, and equation number 2 is y is equal to negative 2x plus 4. Now, why are we going over this? The reason why is that this is substitution. Both of the equations are solved for y. So if we wanted to solve this systems of equations, we could do that by setting the equations equal to each other. So 4 over 3x minus 6 is equal to negative 2x plus 4. And the best way to solve this is just to get rid of the fraction. So we're going to multiply by 3, multiply by 3, multiply by 3. Basically multiply everything by 3. So the fraction is going to simplify to 4x. Negative 6 times 3 is negative 18. Negative 2 times 3 is negative 6x. And 4 times 3 is 12. Oops. So now we're just solving a regular equation. So we could add 6x on both sides. 10x minus 18 is equal to 12. Combine our constants. So we have 10x is equal to 30. And once we divide, we know that x is equal to 3. Now don't forget, because this is a common mistake, don't forget to go back and get the other variable, the y. So now we go back and we're going to use the equation that does not have a fraction. Y is equal to negative 2 times 3 plus 4. So y is equal to negative 6 plus 4. Y is equal to negative 2. So the solution to this last problem in systems of equations is going to be the order pair 3, negative 2. Please be mindful of this type of substitution problem because they will ask you and it's not always as obvious compared to when we have it in standard form. Really hope that this video was helpful for you, math family. If it was, smash the like button for us, subscribe to the channel, and leave comments down below if you have questions on this video or if there's topics you'd like to see on our channel in the future. Thank you guys so much for continuing to watch and support Algebra 1 with Mr. Peters.